Okay. All right. Good morning, good afternoon, good evening, everybody. Welcome to this December edition of the IREE community meeting. Today we have a couple of topics. Sort of like starting off with, a presentation or discussion on like IREE and OpenXLA, and like the collaboration plan there, and just how everything fits together, which I think has been on a couple of folks' minds. And thereafter, we have Ben, Open, and Matt talking a little bit about the work that folks may have noticed that's ongoing with respect to distributed execution and collectives in IREE. Quite excited to hear a bit more there from folks. But I'll sort of start off handing it over to Stella and/or Tia. I'm not sure who will be speaking.
Oh, we didn't coordinate on this. Taya, do you want to speak, or do you want me to speak?
My computer is being a little funky, so why don't you start and then I'll fill in. If there's anything.
Well, hey folks, this is Taya. She runs the OpenXLA community, and that's a good lead into what we're going to talk about. We've been working behind the scenes for a while to align these two projects. We've been in the same org and same part of the company, working on similar things, and it's just taken a bit of time to decide what we want to do with the brand, and especially with IREE having come a lot from more of the deployment client side, and OpenXLA coming from the server side. We've decided these are really complementary, and we want to pull them together and invest together. So I don't actually have a solid plan on how this is going to work out, but I like to say that I was in Denver in the when Quest bought US West, and I remember that when they made the announcement, they just dropped a big Q over the US. They had a couple of guys on the roof, and that was how they announced that the merger was happening. So in similar vein, more of an intent, IREE's going to be joining the OpenXLA community and brand, and practically what that means over time, repo organizations and whatnot will get worked out, and which organization holds it. Probably the biggest thing is that I've been working with Taya on for many months is the OpenXLA governance and community standards, and how we do outreach and how we collaborate and all that stuff. And I'll say that IREE's outreach style is very grassroots, and OpenXLA's is that what we're trying to build is something that we can sustain as a more of a foundation level thing that can go forward for a long time. So I'm really looking forward to combining forces on that, because it feels like it's the time that IREE graduates a bit in terms of how we do community management, governance, work amongst ourselves and all that stuff. And it was just not making any sense for us to do that in two silos. So that's basically the what we know right now. I'll hand it over to Taya.
Yeah, I'm in the middle of finalizing like a first proposal for governance for the OpenXLA project, and hope to publish that this week for feedback from the community. So we'll definitely include the IREE community in some of that feedback, I think. But essentially what we're trying to build is, a good hybrid between kind of hierarchical governance that makes it very easy to scale, very easy to understand, like where different groups' technical scopes for decision making are. So to kind of avoid a lot of stepping on toes and gray areas for who actually can make decisions, but at the same time, definitely decentralize the decision making as much as possible, and kind of, relying on the different kind of subgroups that are most actively working on the code to largely manage all the decisions themselves without feeling like, they're easily blocked. So we're kind of trying to have a very clear decision-making structure, but then also as much as possible defer to code owners in terms of, how they decide to, design their specific areas, and only having kind of that hierarchical structure to deal with escalations where the maintainers themselves are like, hey, we need help figuring out what decision we should make. So from like a governance perspective, I feel pretty happy with where we've gotten. Some of our basic principles are that, like, we're seeking to make consensus-based decisions. Also that, people's responsibility in the project are largely tied to their technical contributions for technically scoped areas. And then we're also figuring out how to open up project responsibilities for people who are making lots of non-technical contributions as well, and where that fits in. As far as like active collaboration and cross coordination between the groups, like, are we doing this largely on Discord? Are we trying to set up a discourse forum? Are we going to be driving this through like mailing lists and RFCs? I think that is something that we're still kind of trying to build and figure out. And I feel like the IREE community, we have a lot to learn in the OpenXLA community from like how the IREE community manages, like, kind of that tight feedback cycle of collaboration, which I think, could use more structure as far as a governance model perspective, but also I think, as much as we can borrow from the kind of more grassroots style of active collaboration, the better. So I think that that's probably something we'll dig into a little bit more in Jan, and would love your feedback on that. Just like, how do we work most effectively together across
90% of it.
Teams.
90% of it is cat pictures and dog pictures. We don't discriminate. So yeah, and I'll also mention that that a lot of the corporate entities that I work with have been asking for this for some time. The grassroots is great, but actually growing this up a level and having a roadmap that gets us to kind of a neutral governance and perpetuity is what people want if they're investing a lot of resources. So I see this as there were a few paths forward to get there, and this is the one that made a lot of sense, and in terms of addressing that feedback. Any thoughts or questions on the exciting topic of governance? Okay, well, let's get into the technical part of the conversation.
Awesome. Thank you very much. So I think that's actually like you're Ben for the more technical side of the discussion. We'll see the tag team for you guys.
All right, so let me prepare the slide.
I mean, I was going to ask if the governance council will be blue or red, but I think that discussion, we can defer also. So.
All right. Hi, I'm Okwan, and our team is working on the SPMD and scaling to support distributed computing through the IREE stack. So it's in the early stage. So I want to talk about the progress so far. So okay. So yeah, it's very clear we need to scale up the compiler and runtime to support the large models. So we need to scale up for latency, and also we need to scale up for the data size. Traditionally, it's mostly about the training. But these days, we are seeing more heavy inference workload for some models, which take more than a second. So normally inference side wants to have a latency less than like a few tens of microseconds, right? So this work is a work in progress, and there are many parts to finalize for the whole step. So let me introduce the IREE step. And we have an input source, and we have a flow IR, stream IR, and HAR IR. And also we have a VM instructions, and those VM instructions call the driver runtime APIs for each target. So this is a recap about the IREE compiler stack. And this is the progress we are making in the IREE stack. So we want to target the, we want to support JAX PMAP for the initial outcome. And we already added support for the stream HAR VM and also driver APIs. And I'm working on the Nickel side and the other parts. So so we are currently targeting at the NVIDIA devices, and we want to use the Nickel communication API from NVIDIA, which is open source, so we can easily modify and deploy in our setup. So that's very nice. And Nickel, NVIDIA made a Nickel library because they have a very fast direct communication among the GPU, even across the distributed nodes. So I want to give you a brief changes in the IR steps. So as I mentioned, we have a stream, HAR, VM, and driver and API changes. But there are missing part, which is this between the front end and the stream IR. So we are still surveying what would be the best IR for this layer. So in the the normal distributed computing APIs normally has a communicator and information about the current process ID, sometimes called the rank, and the total number of processes. So in this case, in the stream IR, we have a operation to create the channel, and also we have a API to query the rank and the count, which is given by the environment or command line. And so we have an API to create the channel. We also have an API to create the default channel. And there is also the collective communication op. So then in the middle, we have a stream async collective op, and which is lowered into the stream command executive. Sorry. And during the progressive lowering, the stream op is lowered into HAR, and the HAR is lowered to VM. So I will show the HAR ops here. So the theme is the same, right? We have a rank and count information, and we have a channel value, and we have a comment about the collective operation. So in the VM, into the VM, we have the same information, channel and rank and count, and eventually we have a high command buffer collective operation. So in the runtime, sorry about the small fonts, and in the runtime, we have a corresponding data structures, right? So we have a high channel data structure, and we have a related APIs. like a channel create and query rank and count. Then this API, the high-level API, is connected to the each target's driver API. In the CUDA runtime, we have this nickel channel create function, and which eventually calls the nickel init rank config, which creates the nickel communicator. And we also have a submit batch command, and then that eventually calls the nickel function, communicator function, based on the op kind in the batch entry. So that's the overview about the compiler step. So as you can see, the communication API, it is pretty much like orthogonal from the existing compiler step. So just adding a few support for the channels and operation, we are pretty much ready in the compiler stack to support the distributed computing. So here is the nickel functions exposed as a dynamic library function call, and here I added two IREE specific API functions in line 3 and 4. So nickel init root, which actually initiates the server role for the root process, and nickel get unique ID from the environment. So this is to specify the server address, and this is to work around not using the MPI communication to broadcast the server ID from the root process to the other processes. So with the help of these two API functions, we can directly use the nickel function without the initial MPI bootstrapping.
Yeah, the important thing there being that IREE as a library doesn't actually own the context of the application or how you would set up an application or a framework to layer these things. So the kind of things that traditionally are done with kind of broadcast and stuff like that are something that whatever is integrating IREE would provide. So that might be something like PGART on the Jack side, as it handles distribution and launching sharded processes and stuff like that. And IREE as the library will basically just take that and use whatever the higher layer does. So should integrate well with any existing application that is already using collectives or already has a communication mechanism between its shards.
Yeah, thanks for the information. Yeah, yeah, we want to make the IREE stack as flexible as possible. They can be called in various situations. So our plan is so this is a very like immature stage, but we have a kind of well-established setup right now. So we want to do the full test from the stream up to the runtime call, and we want to verify all the communications. And also, as I mentioned, there is some IR design and this decision needed between the front end and the stream up. So we wanna. There is a CCL effort to make the collective communication supporting the IR, and we want to survey more options to support the various languages and to represent as generic as possible. So also we are trying to integrate this stack with JAX as an initial stage, and also we want to support large models with the GPU cluster, and you know the major challenge in the distributed computing is how we do data partitioning and generates communication. Actually, the communication cost is the most expensive one in the distributed applications, So data partitioning and communication optimization is the key part of the optimization process. So there are several options we have. So TensorFlow already has GSPMD stuff, so we can explore it more. And there are some other open source project that tries to do the automatic data partitioning and communication optimization. And so that's gonna be our next survey. What would be the best choice for the best performance? And so we are currently targeting a single device per process, but there may be some cases where the performance might be better with the multi-device in a single host. So that can be also supported by our IREE runtime stack. And currently we are targeting at the NVIDIA devices, but as you can see from the stack, the communication library actually is well abstracted under the driver runtime side. So we can easily adapt the other communication libraries like MPI or some other communication APIs. So also we can support the other targets like CPU and some other accelerators. So that's it. And any questions?
I could probably, if anyone's interested, talk a little bit more about the big missing layer that was on one of the earlier sheets at kind of the flow level. There's interest in that.
I mean, I'd be interested.
Okay, so one of the goals with all of this, as we've been kind of going through, is to connect to the existing libraries that we have. Nickel being one of them. Intel has a library that does CCL stuff, MPI, etc. And so being able to target those effectively for what you want to use them for, which is mostly the distribution and memory system benefits. Whether you're on a single device and you've got multiple NUMA nodes and you're using a memory controller to perform the operations, or multiple GPUs and you're allowing peering to take care of this on the same device. But there's also additional levels of this that haven't really been explored in a lot of cases outside of very specific scenarios for things like halide on a particular device. But where even on a single device, you can still get benefits from collective operations and by modeling them as collective operations. And so kind of classic example of that is things like vertical tiling, and where you might want to take a single stack of a very non-parallelizable model. You've got data dependencies between each layer, and partition each of those layers into like say 4. And do that down the entire stack. And if you can do that, then you now create, instead of one, end-to-end latency bound, you now have 4 times 1/4 latency bounds. And if you can run those out of sync even a slight bit, you can cover for latency on the GPU or on the CPU. So a lot of the benefits that we talk about, usually when people talk about collectives, are on the distribution scale. But this also applies to running on single devices on single hosts. And so one of the goals with all of this was to get to a model such that we could both use the kind of classic APIs like Nickel and things like that, as well as within a single device get all the same benefits. And where that intersects then with what our representation is at the higher levels is we want to be able to optimize just like we do with the other dispatch workloads we do. So examples of that would be, if there's no magic with collectives that make it go faster than the speed of light. And so if you're doing a collective, reduce across, 10 gigabytes of data across 100 machines, all those bits need to move. And so one of the things we can do as a compiler when we can optimize is do things like pull out additional levels of that. So for example, instead of doing a 10 gigabyte reduction across a bunch of machines, if we could locally on each machine do a 1 gigabyte reduction, and then do 100 kilobyte reduction across machines, that makes things a lot better. So a lot of what we really want to be able to model at the flow level is the same kind of fusion opportunities, the peeling opportunities, tiered reductions and things like that. And we need something a little bit more flexible than a front end already coming in with collectives as stateful, in place, allocated operations. Doesn't mean that we can't also support that. So if you're coming in from a front end where the user has explicitly typed out, send or receive or something like that, we can tunnel those through. But really, as we're plumbing this through the entirety of the IREE stack, we really are thinking about what does it mean when IREE itself is producing the collective operations. Again, even if you're on a single machine and a single GPU, we may still produce these collective operations. How do we optimize those when we're talking about linalg operations, where we might be peeling off some of these collective operations into things like linalg generics with reductions that we're then fusing with producer operations or consumers. And yeah, so as Aquan mentions, there's quite a few ways to model that stuff, and I think because a lot of this has kind of only been done in distributed situations, there hasn't been too much prior work here that we can kind of crib for some of this. The next step will be getting the front end, like Jax, for example, has already written out and decided how to shard this. But our eye is really on the future where we'll be doing this ourselves. And then on the runtime side, as Aquan mentioned, we have the nickel side right now. That the channel is a virtual interface, and so we will have nickel because that is for anyone using NVIDIA devices pretty much what you want to use if you actually want to get good performance there. So we'll have that, but it is a virtual interface, and so there can be alternative implementations. If someone already has some collective mechanism, you're in a data center and you've got your own memory subsystem that you're targeting with your collectives, we can plug in there. An example of that would be libfabric and what that's used for, kind of as a pluggable interface for transports for collectives and things like that. The goal being that we will eventually be able to allow you to plug in these different collective channel implementations across the different backends, whether you're using CUDA or Vulkan or CPU. You'll be able to plug in kind of whatever you want there. And then I think the final thing was the thing that we're currently missing near the front end is the send and receive. Specifically, those collective operations have some implications around what a compiler is actually able to do because they're side effecting and they're kind of materializing tensors out of thin air. So there's still some design work to be done there. There's nothing today at the flow level that allows us to model those kind of operations. So the initial set of collectives that we support are exclusively the structured collectives like reduce, scatter, and gather and things like that. Which is in most cases enough for the basic Jax programs we're running. If someone does have examples of good abstract collective operations in SSA form, that would be super useful. Please reach out. Yeah, I think. If any other questions?
So, Brian?
So I have a question. So you mentioned that you want to be able to initialize like the collective backend in some like to offload it to the application, the user of IREE. So do you like, because you described there like very specific to Nickel initialization functions that bypass the necessity of having another MPI library to bootstrap the initialization of Nickel. So do you think there is like some way to do it like some more general way where you don't target just Nickel with this, but kind of, I don't know, like kind of some non-specific way to be able to initialize the.
So when from the programs that we emit from the compiler, there's kind of two models depending on which front end you come from. One of them is, for example, in JAX, when it pre-shards the program, and each input the IREE compiler gets is an entire shard. And in that case, the JAX runtime is expected to have, done the interchange of the IDs and stuff. And so we'll just take those in. The other way, though, is explicit channel creation. And so if your API, and JAX has a mode for this, where it will produce one program that can kind of polymorphically act as any shard, and it can have multiple channels at any given time. So you can have, ranks 0 through 3 in one channel and ranks 4 through 8 in another. And, there can be overlap and stuff like that. And that's something that's programmatically controllable. I think maybe what you were getting to there is who creates the channel. And I think that is a front end question. So if you're using the default channel, then we'll use whatever parameters you passed in when you created the device. But just as IREE is,
when you create, I know that there is in the runtime, there is an option to pass generic parameters, but they would be we want them to be the same for trying to be the same for all backends. It might be very specific to some CCL backend, but
correct. And so the idea with that is IREE is a state, it produces stateful programs. And so just like you can add setters and getters for your model stateful variables, for example, you can do the same with channels. And so an application wanting to provide its own channels that it's configured in a backend specific way, it can literally call what the nickel example here was, IREE, HAL, CUDA, nickel, blah, 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 create. Whatever concrete implementation you want, whatever parameters you want, whatever configuration you want. If you're wrapping an existing communicator that you already have in your application, application does that and then has a setter on the model that says set the channel to use. And that channel is a variable within the model that is then used. So we can support the cases where the model itself, as it's compiled and then running at runtime, creates the channels or acquires the channels, or the situations where users want to explicitly say, use this channel for communication. And that gives you that control of, I outside of IREE entirely have my own channels and communication mechanisms and things like that. In IREE, I just want you to use this, versus the, nickel is built into the box if you're using the CUDA driver, and you can just get that for free.
Hey, Ben, is there maybe a missing boil it down sample for some of this that might help?
There's a lot of missing samples.
Yeah, well, what I'm getting at is that this is at that really weird intersection where, we're used to taking programs directly from front ends that are kind of operating in a much more monolithic fashion in the old world. And, we ultimately need who's generating the input to IREE to adapt in order to be the best thing. So I just live at this intersection. I know how hard it is to talk across 3 different levels of the stack, especially when no one wants to touch the one that's named TensorFlow and all that stuff. So yep. I'm just wondering if there's a simple, or at least a hermetic example that says, hey, this is how IREE wants to use collectives.
Yeah, and I think this is kind of the classic problem of building a framework is we're enabling you to do anything, but what everyone wants to do is special and unique. And so I think for this initial work, we don't have anything running yet. The nickel stuff isn't wired up. We're not yet emitting the ops. So this is still very early. As we get things working, we'll have samples that show off some of the different usage. My hope is to go through the nickel getting started guide where they have the 3 or 4 different ways to initialize a nickel channel, and basically have those equivalents in IREE. And then if there are other frameworks we wire up, we can do the same.
Yeah. So Yeah, I'll add one addendum to what you said. You know, we're making a framework that lets you do anything, and people want that. But I think people also definitely like when you got in and got your head joined around the whole thing, and like, what's the recommendation, you know, and then that'll be copy pasted. So I think that Doe had a question.
Yeah, just really quickly on that. The hardest part about all of this collective stuff so far has been finding anything but hello world collective examples. So if you are a user who has feelings about collectives and has use cases and real stuff, please share them. It'll help us ensure that we're getting the right samples and we've got the right API hooks and stuff. It is literally impossible to find anyone actually using collectives in an interesting way. So very much appreciate that.
It's all very vertically integrated. So Doe had a question of I hear that IREE produces stateful programs. In my experience, input to IREE is not stateful, it's functions. Am I missing something? So we do in some situations, we have built IREE in order to the module is stateful. It's true that most ML frameworks are tracing out a single entry function that is stateless. But this is what we were just talking about, that the input to IREE can declare globals, it can declare initializer functions, it can declare other things. And then within the functions that you're actually evaluating, it can load those, use the channels, use the handles, and put things together. The thing that I've actually doing that in depth would require a lot of work at the high level of the framework. What I've done in the past, if you look at the IREE JAX project, is basically say, what can we do by wrapping an otherwise framework generated stateless function with state? And that's kind of the direction. The direction that's probably the most profitable for the near term is, use the frameworks to generate stateless functions, and then augment the model and create a new wrapper function that delegates to that in some way. But this all requires front end work to leverage completely.
Yeah, and we do have a variables and state sample that's using the TensorFlow representation, because TensorFlow is one of the few that actually has variables. And so that one, at least if you're interested to see how state can be represented and then tunneled all the way through, that's a good place to start. But like Stella said, the JAX stuff is probably more interesting. But one thing too is, even if the input does not itself represent a stateful program, the IREE compiler through various stages will often generate state. And so, whether that's, one-time initialization of tensors that we hoist out and move into initializers and then store as stateful variables, or the rest of the program internals. When we launch and we compile all the CUDA kernels or Spear V shaders and things like that, we retain those in the program as stateful handles. So yeah, it's really a question of what kind of programs are we ingesting and how do you model those with state, and the rest kind of just is a program.
You're welcome.
Nice. Well, I mean, I think this is the time of the community meeting where, it's open for questions from folks from the community. Of course, we'll have our next one probably like middle of January. It's roughly a month from now. I'll also mention next week is the OpenXLA community meeting. And so given what you just heard earlier, we'll also be there to join that meeting. So, to give a plug for that. But yeah, so the floor is open if folks have any other questions. I mean, awesome. Because all that well explained that everybody understood. That's great. I think that just means we have more time for coffee.
Or beer.
Or beer. This is true. Very time zone dependent. That's very true. I just want to say thanks everyone for joining. I'll send out the email again for our next meeting soon. Please use the form as well to highlight topics of interest. Like you saw today was something work in progress that we're doing on. So just to give an idea of some of the things we're doing, and so, it's great to hear from community with respect to specific interests. And yeah, see you again soon.
Thanks for organizing, Jock. I really appreciate you actually being proactive about these community meetings. They're really easy to just blow by on topics and whatnot.
Great.
All right. Thank you. Bye.